Hello, everyone. My name is Topalsky, and I'm a data science and analytics solution engineer at TIBCO. And today I'll take us through a use case and a demonstration using data science and analytics for threat detection. But before we get into the demo, I wanted to talk a little bit about TIBCO and just give a background of who TIBCO is. So TIBCO has a breadth of solutions spread across 3 product families that connect and unify your data and predict the future. TIBCO is a globally trusted partner. We've helped over 60 agencies increase effectiveness, support oversight, and promote transparency across commands and programs in, Department of Defense, intelligence communities, and civilian agencies. And these 3 product families, the first one is Connect. So this pillar includes API management and integration, events and messaging, and process automation. The Unify pillar is our data management and virtualization area of expertise, and the Predict pillar is the analytics and data science capabilities or product family. And on this slide here, you can see that all of these solutions can fit together to create an end-to-end solution. So TIBCO really understands and has capabilities to support the entire data journey. But the key takeaway here is that these solutions are tightly integrated, but they're also modular. So they allow the customer to build solutions that utilize as much or as little of the domain capabilities as needed. So that's just a background, but today we will be focusing on the analytics and data science capabilities, which is a strategy that I'll refer to as hyperconverged analytics. So this is TIBCO's analytics strategy that includes data science, data prep, data visualization, and even data management and streaming data. And these capabilities converge together, build a very mature analytics strategy that represent kind of the next generation of analytics. And for the use case that we're talking about today for security and systems protection, hyperconverged analytics, it's used for anomaly detection, threat identification, predictive protection, and process optimization. So the big differentiator with this solution is the predictive protection component. So that's being able to proactively prevent attacks and respond to threats in advance. So that's kind of what will be the focus of the demonstration today. But before we get into the demo scenario, I wanted to talk a bit about the data science process with TIBCO's hyperconverged analytics strategy. So this strategy allows users to move beyond time-consuming and manual analytics to an advanced data science process that targets specific actions in an accessible way. So on the slide, you can see that this is a process that's a continuous loop. So from deploying an unsupervised model to retraining and improving the process on a continuous basis. So what we'll see today is that we're starting with an unsupervised model for anomaly detection. So what this is it's a model that doesn't need to be told what an anomaly looks like. These anomalies and potential threats or unusual patterns in the data are detected automatically, because the model is detecting these underlying patterns in the data. So the solution isn't relying on business rules or statistical measures, but we're going to be looking at how a neural network can be used to identify these behaviors. So this is great, especially if you don't know where to start or if you don't know what an anomaly looks like. It helps give a baseline or kind of a starting point for what to identify. And then from there, more specific supervised models can be built or specific policies can be used to enforce, different rules based on the model outputs. And you can also tag outliers and based on this baseline model, give feedback to additional supervised models, which will help improve the process of identifying threats. So as time goes on, this is a cumulative process which improves. So now I'm going to switch over to the demo. Just going to switch here. So what we're looking at is an anomaly detection dashboard analysis with TIBCO's visual analytics tool Spotfire. And I wanted to note before we get into the examples of the demo that what we're looking at today, it can be leveraged as a starting point, but but the full power of this tool is available to expand or customize the needs of the user. So this isn't static or preset. this can be used, as is, but you can also, add additional visualizations, change the colors, add, additional models. So this is not set. You can customize this and expand on this dashboard that we're looking at today in any way that's, necessary for your organization. So some features to highlight of this tool. The first is an AI engine, where here are some of the variables and the underlying data. When you select the variables, you can see some suggestions here. If you select more than one variable, that are coming up with some visualization suggestions based on the relationships between the variables and the data. So it's nice to, for an analyst or a data scientist or a user to be able to have that recommendation engine to help, guide an analysis. This is also fully brush linked and filtered, so you can, select an area in one chart and see how the visualizations react to your selection. And you can also connect to multiple data sources and also more than one data source at a time. So you can see here are just some of the examples. You can connect to relational databases. Data can be held in memory, in database, or a hybrid. So again, this can be just customized however, is necessary for your organization. There's also, we won't spend too much time on this, but there's inbuilt data prep as well, where you can do joins and make transformations. This is not separate from the tool. This is actually included, but it's, a very powerful data prep tool as well. So getting into the actual demo scenario, this demo was put together using log logic data and Spotfire, but again, there's no dependency on log logic. This can be applied to different data sources. And what we're looking at in the first page here is just some descriptive analytics of log data. So we have in this chart we have a graph that has the log frequency color coded by action. We have the distribution of successes and failures, by action, the actual logs themselves, and a user analysis. So again, you can, select different visualizations, points and visualizations to just analyze, specific areas to drill down in. You can highlight multiple points at once. So if we wanted to analyze, just look further into this user's profile, we can highlight some of these points here. And we can kind of see a user profile analysis just through selecting some points in the visualization. And at this point, we're just looking at some supporting visuals with our log data. We haven't deployed the model or, used any advanced analytics methodologies. But we can already see just from looking at this action distribution chart that there's a high number of authentication and login failures with this user. And while we can also see that there's a high number of successful logins for this user as well, but for authentication, we're seeing lots of failures with, the proportion of successes is very low. So this is something that an analyst can decide is this out of the ordinary, or, we could also just, wait to see if the model will pick up on this behavior as well. So going on to the next page, we're still just looking at, getting an exploratory analysis of the data. We haven't deployed any modeling yet, but this chart is an example of a more advanced visualization in Spotfire. So this is showing the relationships between the actions. So this network chart here is showing every user connected to every system. The width of the line indicates how often the connection occurs. So the thicker the line, the more frequent the connection. And the node or the circle shows how many times the system has been connected to. So you can see right away this example here where we have an unknown system making frequent connections. So this very thick line. So you can investigate these patterns some more, or see if this is something that the model will pick up, later on in the demonstration as unusual behavior. You can also use filters as well. So right now we are looking at all of the actions, users, and systems. But if we want to kind of drill down into the user profile that we were looking at last time, or in the last page, where we're looking at authentication and login for this user, we can see that in the network chart that this user is connected to a few different systems. So again, that's something an analyst can decide, if that's something you'd expect or not. So that summarizes kind of how this tool is powerful for anomaly detection and descriptive analysis. And there are already a couple of things that we've pulled out and a couple of scenarios that we can investigate, without even deploying any data science or modeling. Although we'll see how the modeling component, improves the objective better for identifying potential threats. So the next page here, we're getting into some of the more statistical and data science analysis, but we have not yet gotten to the point of the neural network. What we're looking at here is a more common or standard way to analyze the frequency of logs at different time periods and look for outliers. So this is kind of a process control analytics methodology that's widely used in manufacturing as well, but you can see how many times the system has been accessed in these 4 different time periods, so 2 hours, 1 day, 3 days, and 7 days. We also have a daily outlier pattern chart here where we can see where the outlier, the anomaly has, on what day it's occurred. You can also, this is again fully brush linked, so we can make a selection here and be able to look at when that actually occurred and when the outlier is. There. Let me unset the markings. All right, there we go. Okay, and you can also, there are some dynamic inputs as well. So you can change the detection limit, the detection levels as well. So you can detect, unusually high levels of logging for different detection levels. These can be, adjusted automatically, and there'll be, different levels of suitability for, the different time periods. For example, for the 2-hour detection level, this detection limit might be, too high. But this is something that an analyst or a user can dynamically change based on the tolerance that they're looking for. So this is just another way to detect outliers and interrogate points in the data by using a standard statistical process. But now we'll look at a more advanced modeling components on the next page here. So this is our machine learning modeling building page. And this is, we're getting to the part where we have a Python neural network model deployed on our log data to look for anomalies. So here is the model building page. And I wanted to note that there are many different personas or users that will be working with these analyses. So this is definitely something that a data scientist or an analyst might be interested in. Kind of your end user or somebody who's just looking for a bigger picture and kind of the modeling results might not be interested in this page. So I won't spend too long on it. But this is just to show the power of the tool, how models can actually be trained, tuned, validated, and actually embedded into this tool. And we also use this page to assess how the model has been trained. So essentially to make sure that the model that we're using on our data has been is suitable to make these predictions. And so we know that we can trust the predictions and have confidence in what our model is saying. So that's essentially, what this is for. And again, I won't spend too much time on it, but I will just show for, the analysts or the data scientists in the audience that this is a Python model that's embedded in the tool. This is, what it looks like. It should be familiar to, people who are have Python scripting practices. But the advantage and the difference of having these types of models and data science in the tool is they can be parameterized. So these inputs here can be dynamically changed, and by the users, it's just a text box, and are actually informing what's going inside of the model. So, these type of parameters for the neural network model can be changed if we see that the training and validation of this model is not, suitable. But this is just to show, how a data scientist might interact with this tool if they wanted to actually execute the model directly from this interface. That can be done. It also hides some of the complexity of a Python neural network model for those who are maybe interested but not as familiar with the process. They can still consume the information presented here. Now we will go on to looking at the actual model results. So at this point, we're looking at predictions that the model has made on data the model has not seen yet. So to explain what we're seeing here, this plot here has an error rate for the time period, and you can see that anything that's above this detection level is a potential anomaly that the model has flagged. So you can see that there are some points here that are showing highly irregular behaviors based on the model's predictions. And we can highlight these points and look closer and see, what's actually happening here. So if we highlight some of these points here, we can see some of the actions that are associated, the actual logs. And we can actually also use this histogram here to highlight some of the points that are way outside of the detection level. So that's indicating unusual patterns or behaviors in the data. And we can see, again, the logs that are associated in some of the actions and frequencies. You could also, filter in on just certain actions or users or hosts. If we wanted to look at some of the user profiles here, we can see that some profiles, there are not a lot of unusual behaviors flagged, but some, for example, like root, we could highlight some of the points in this user and see, what's going on here. So at this point, we've identified and gotten a profile of some, things we'd want to look into more, but we want to understand why the model is saying that this is an anomaly and to get some more information of why this has been highlighted. It's not enough to just say, these actions or this profile is being highlighted. We want to know why, so we can, verify what's actually going on. So that we can do in the root cause analysis page. So we can see here, again, we have the anomaly, the error rate profiles here. We also have some visualizations that are showing key drivers and why the model is saying that these are potential anomalies. So we have a word cloud that's performing natural language processing on the actual logs themselves. So this is just really easy to kind of read and spot some of the most common text logs themselves. We have a variable importance chart, which is showing which of the variables was the most influential in saying that this was an anomaly. We also have a variable analysis tree map here as well. So if we want to, let's look at maybe some specific actions here. If we want to highlight some of these authentication actions here. So what we're seeing here is that with authentication is that some of these variable importance drivers here, we're seeing a lot. We see source IP that comes up as having a pretty influential impact on the model, saying that this is an anomaly. So this is essentially saying that authentication is coming from a particular IP at a certain time. So that's certainly something you would want to look into. So what is an action that you can take from here? So from here, you might want to tag these anomalies. So what anomaly tagging is, the idea here is you could either add a note to pass on to another team member to look into further, or you can use tags to improve the feedback from the model itself. So if an analyst has looked into these authentication coming from this unusual source IP, you can tag this as an anomaly. And now the model will be able to pick up behavior like this better and easier, and going back to that data science loop faster, because it has feedback actually validating that this type of behavior is something that is unusual. It could also work the other way. You could say, we've looked into this and this is normal behavior, so then the model will know, don't pick up this, don't identify this as a potential anomaly. This is normal behavior. You can also use these tags as actual data points to train and develop more specific supervised models as well. So these are just some examples to show how unsupervised modeling can be used for anomaly detection and cyber threat detection. And I think this is a really good starting point to especially inform where to begin and what to look for, because it's often very difficult to identify what patterns to look for, especially if you have tons of data coming from Splunk or LogLogic or whatever your log data is coming from. This is a really good place to start using data science and being able to develop a data science strategy and additional models that you can use in a production environment to prevent cyber threat attacks in a proactive manner. So not just responding to, but being able to predict them before they happen. So I hope you all enjoyed the demonstration today, and I'll open it up for questions. Feel free to tell me to go back anywhere if there's something that you want to see in the tool or about this use case. Feel free to let me know. All right, well, if there are no questions, I can pass it back over to Chris.
All right. Yeah, thank you so much, Danny, for that great presentation. And, do you have any follow-up if anyone wants to get in contact with you?
Yeah, definitely. I have some contact information in the read ahead that was provided, but I'm also happy to send a follow-up email with my information. If you have any questions, I'll also say that we do have organizations using this solution for cyber threat detection currently. So this is something that we've spent a lot of time developing and are working with organizations to build their custom solutions, kind of with this type of baseline in mind. But yeah, if there's any information on how this could be tailored to your specific needs, or if you have any would like to see a demo that's tailored towards a specific use case, feel free to reach out and I can provide some contact information.